Hello there. Well, some people like to use a slightly posh name of the exponent, and others like to use the name powers, but we're going to call them plain old indices. Let's have a look at this formula for electrical power. We can see that in this case 2 is the indices. Power equals voltage squared divided by resistance. For communication satellites, we can see that the equation for the signal loss in space, again 2 is the indices. And if we understand how music's sampled, well, in this case it's -n as the indices. And if you need to understand an aircraft's lift capability, well, in this case 2 is the indices. Let's have a look at how we calculate using indices. Well, we've gone to Google Calculator and we're going to do 3xy, and then I'm going to type in 2 and we should get 9. Yep, there we go, got 9. Easy as that. However, on Apple, theirs isn't xy but yx, and Casio, it's x to the box, x indices box. And on this calculator they use the caret sign or the top hat symbol. So in actual fact what we see is that there are 4 symbols meaning indices or power, and they all do exactly the same thing. So how do we use indices and formula? Well, to do that we need to understand and use the laws of indices, and that's what we're going to do next. The laws of indices are listed here. If you press pause, and I'll just wait for you until you've squiggled those down. A to the 1 equals A. Let's stick a number in. A, remember, A is just a number. So suppose A is 5. 5 to the power of 1 is just 5. If you've got one lot of 5, it's just 5. If you've got one lot of 7, it's just 7, so 7 to the power of 1 is just 7. So what would bananas be to the power of 1? Well, it's just bananas. We've got a to the x times by a to the y equals a to the x plus y. If we take 5 again for a and say 5 to the power of 3 times by 5 to the power of 2, so that means it's 5 to the power of 5. And we can see the pattern here. Maths is always about watching for patterns, logical patterns. So the pattern is we've got 5 to the 3 times by 5 to the 2 equals 5 to the 5. So we're just adding the indices. So that leads us to a to the power of x times a to the power of y equals a to the power of x plus y. So what is a to the power of 8 times a to the power of 4? Well, we just add the indices, so we get a to the power of 12. So that leads us to our third law, which is a to the power of x divided by a to the power of y equals a to the power of x minus y. And we can see how that works, because if we substitute in, say, 5 where a is, and for x 7 and y 5, then we get 5 times 5 times 5 times 5 times 5 times 5 times 5 divided by 5 times 5 times 5 times 5 times 5. And then we divide them out and we end up with 5 times 5 at the end. So in other words, 5 to the 7 divided by 5 to the 5 equals 5 squared. So we can just subtract the indices when we're dividing these three. What is 8 to the 12 divided by 8 to the 4? Well, this time we just subtract the indices, so it's 12 minus 4, which is 8, so it's 8 to the power of 8. So that leaves us with the last one, which is a to the power of 0 equals 1. This is one people usually get stuck on. But look, it's simple. If we go back to the previous one, which was a to the x over a to the y equals a to the x minus y. And this time what we're going to do is we're going to say a equals 5, and we're going to say x equals 3, and also y equals 3. So we've got 5 to the power of 3 divided by 5 to the power of 3. Well, that equals 1, doesn't it? But it also is 5 to the power of 3 minus 3. which is 0. So 1 equals 5 to the power of 0. But we could stick any number in for A. We could put in 6 for A, or 7, or 321, whatever we like, and we will get 1. Why are these all equal to each other? Well, the answer's simple. Because they're all to the power of 0, they all equal 1. Now let's look at a to the indices m to the indices n. That turns out to be the same as a to the m times n. For example, let's do 3 to the indices 2 to the indices 4. That's the same as 3 times 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 3. There are 8 lots of 3 there, so that's the same as 3 to the power of 8. So indeed, 3 to the indices 2 to the indices 4 is the same as 3 to the indices 8, which comes from 2 times 4. That goes to demonstrate that a to the m to the n is just the same as a to the m times n. So what is 25.6 to the power of 6 to the power of 3, or 25.6 to the indices of 6 to the indices of 3? Well, all we have to do is multiply 6 by 3, so that gives us 25.6 to the indices of 18, or to the power of 18. And finally, let's have a look at fractional indices. So we've got a with an indices of 1 over n is equal to the nth root of a. Well, what does that mean? Well, let's take, for example, 9 with an indices of a half times 9 with an indices of a half. That'll just be 9 to the indices of 1, which is exactly the same as just 9. If we also have a look at the square root of 9, and take the square root of 9 times the square root of 9, we'll also get 9, because 3 times 3 equals 9. So what we've done is successfully demonstrated that 9 with an indices of half is exactly the same as the square root of 9. More generally, what we could also say is that a to the half is exactly the same as the square root of a. And we can generalise even more, because we can say that a with indices of a third times a with indices of a third times a with indices of a third is equal to a. So a to the third must be the third root of a. More generally, even still, we can say that a to the 1 over n with an indices of 1 over n is exactly the same as the nth root of a. Let's have a look at how fractional powers work on a calculator. So if we wanted to do the square root of 9, we could just type square root of 9 equals and we get 3. Or what we might do instead is type 9 and then this time do xy brackets and then put a half in there, so just 1 divided by 2. Could put 0.5 in, but we'll do 1 divided by 2 and that should give us 3. Yeah, exactly the same as the square root of 9, which is what we'd expect. And if we wanted to do the cube root of 27, we'd do 27 xy and then brackets, you guessed it, 1 divided by 3 brackets. And that should give us 3, yeah, because 3 times 3 times 3 is 27. Brilliant. I hope that's been helpful. I hope I've put enough examples in there to help you. If you need any more, please let me know. Send me a line on Twitter or whatever you like, or email me. And I'll try and do the best I can to give you a bit more information. But you should have enough material to be able to have a good go at your P1 now. Okay, let me know how it goes. Best of luck. See you next time.